Hello and welcome back to California Geology. Today I want to continue on with earthquakes and talk about intensity. And so intensity is a different way of assessing an earthquake. And intensity really is a scale that's related to how the earthquake affected people and buildings. And for example, if we have a large magnitude earthquake, magnitude 7, magnitude 8 earthquake, it can have a low intensity if it strikes an area of low population and few buildings. So if it strikes out in the desert where there are few buildings and people, then even though it's a large magnitude quake, it's not going to have a whole lot of damage, right? So intensity is really the damage caused by the earthquake. However, if you have a small earthquake, like a magnitude 5 in this case, it can have a high intensity if it strikes under a heavily populated urban area. So that's one of the things about intensity. It's how the earthquake affects people and buildings. Now, there's a scale called the modified Mercalli scale, and it's table 3-13 in your book. And basically, it's a series of Roman numerals, goes from 1 to 12 there. And as you go from 1, it's very weak, nobody feels it. 2, very minor, no damage. And by the time you get up to 7, 8, 9, there's considerable damage for buildings, especially those that are not that are not reinforced. They're not to earthquake codes. And then obviously once it gets to 10, 11, and 12, it's complete annihilation, complete destruction. And I'll show you a PowerPoint on this here in a moment. But this intensity scale is really based on 3 factors. And those factors are, well, obviously the magnitude of the quake. So the stronger the energy released by the earthquake, the more intense it can be if there are people and buildings in that area. Second is your proximity to the epicenter. So the closer you are, the more violent the shaking. And then finally, the nature of the bedrock. And so one thing that can happen is we know that solid, like crystalline rock, if we had crystalline rock, and that would be like metamorphic rock or igneous rocks. We had igneous or metamorphic rock that's hard. And then let's say we have some limestone and sandstone. So it's a sedimentary rock now. And then let's say we have over here some shale. And then let's say a shale, and let's put mudstone as well. And then let's say we had some loose loose material here. Usually this loose material we call unconsolidated. Unconsolidated. And usually that refers to like landfill. Landfill material that hasn't really been compacted, it's not lithified, right? It has, remember the 3 steps: burial, compaction, cementation. So that hasn't happened. And so let's say we have a seismogram. So for the same earthquake, let's say it's a magnitude 5 earthquake, the shaking here would be pretty small in the crystalline rock, because it's a strong rock. When you get to limestone, you'll see a little bit more shaking. Sandstone's more shaking here. Shale, you'll see more shaking. Finally, when you get to the loose material, it's like living on a bowl of gelatin. It's going to really shake with a very large amplitude, right? So this is what I mean by nature of the bedrock. If you're on hard rock, solid rock, then you're going to shake less violently. But if you're built on soft rock, or even worse, unconsolidated loose material, then you're gonna shake much more violently for the same earthquake. In fact, let's look at the PowerPoint here. So again, the intensity scale is again a scale based on Roman numeral 1 through 12, and let's look at, for example, at an intensity of 4 here. It's felt indoors by many, outdoors by a few. At night, some awaken. Windows, dishes, doors rattle, standing automobiles rock noticeably. So usually a magnitude 4, if I'm within maybe 15 miles, 20 miles of a magnitude 4 earthquake, it'd wake me up. A magnitude intensity 4, that would wake me up. And then let's say we have an intensity 7 here. And so here's where now, so you see that everyone runs outdoors. So the way it's affecting people is people are frightened. They're running outdoors. You'll see damage on of buildings that are negligible to slight, depending on the quality of the construction. So those that are reinforced will have very minor damage. But if you're driving in your car, you'll notice the shaking. Let's look at a 9 here. So considerable damage to well-designed structures, structures shifted off foundations, buildings thrown out of plumb, underground pipes damaged, cracks, ground cracks conspicuous. In fact, during the 1989 Loma Prieta earthquake, we actually had some intensities of 9 in the Marina District in San Francisco, and also at the Cypress structure in Oakland, where the double-decker freeway collapsed. I'll mention more about that on the San Andreas lectures. But with those were about 50 or 60 miles away from the epicenter, because the epicenter was in the Santa Cruz Mountains. However, the damaging part here was that these areas were landfill or very loose, unconsolidated sediment along the bay margin. And so the landfill was basically the landfill of the Marina District that used to be part of the San Francisco Bay. It was filled in, mostly by debris from the 1906 earthquake when they had to do all that cleanup. And then in Oakland, it's just really soft sediment there along the margin of the bay. Now, in fact, this is an intensity map that's very similar to the one in your textbook for the Loma Prieta earthquake of 1989. And you can see the epicenter was here in the Santa Cruz Mountains near Loma Prieta. And right around the epicenter, it's almost like a contoured map. You can see we have some 8s, mostly 8s. There's a 7 here. So people in this area felt very strong, violent shaking. So an 8 would be, there'd be damage slight to considerable in substantial buildings, great and poorly constructed. So many homes were knocked off their foundations. Brick walls came down. Walls, chimneys, monuments fall. There was liquefaction and sand ejected from parking lots in Watsonville. So that's an intensity of 8. And so you can see that's all in this area right here. Even Los Gatos, quite a bit of shaking in Los Gatos. Near us here in Saratoga, the Saratoga Library, or the West Valley College Library, had considerable damage with bookshelves falling. But then as you go farther out, you see that there's 7s, and a 6, or there's somebody reported an 8 over here in Hollister. But you can see generally you have 7s over here. And then even farther out, you'll see 6s and farther 5s. And so as you go farther away, the intensity weakens. So 8s, 7s, 6s, 5s out over here. But one unusual thing, note that both at the Cypress structure in Oakland, where that double-decker freeway collapsed, and at the Marina District in San Francisco, we have 9s there. Again, because these were areas of landfill or areas of weak sediment. So here's an example where you can get high intensity even though you're farther away from the epicenter. Now here's basically the same map, but here it's color coded, showing intensities again for that 1989 Loma Prieta earthquake. And you can see that right around the epicenter here in Los Gatos, where the people are living, right? We're having intensities of 9s and 8s and 9s in here, right? 8s and 9s. As we go farther away, we attenuate or get smaller intensities of 6s and 5s over here in the Central Valley. And then what this doesn't show is well, there's a little bit of red here for the Cypress structure that collapsed in Oakland. That's a 9, and then all these triangles are blocking the red that would be at the Marina District here. So this would be the shake map or the intensity map for the Loma Prieta earthquake. And then back in fact, this is the reconstructed shake map or intensity map for the 1906 Great San Francisco earthquake. And here we can see that the rupture, which was over a much larger area, about 400 kilometers of the San Andreas Fault ruptured, compared to only about 40 for the Loma Prieta earthquake. And then you can see all this red. So remember, these are going to be 8s and 9s. Well, actually, red is 9, and these are 8. So really, Santa Rosa had quite a bit of damage all along the peninsula here, considerable damage. San Francisco, and note that the epicenter was probably right off the Golden Gate Bridge there. And you can see we had shaken all the way, really from San Juan Bautista. There's evidence of fracture, surface movement offset from San Juan Bautista all the way here to Point Arena, where the fault leaves the land. So a huge area rupture. And you can see as we go farther out, we're seeing intensities of 6s and 5s in the Central Valley, and then we attenuate to 3s and 2s up in the Sierra here. But still felt over a large area. This is the intensity shake map for an earthquake that occurred in 2007 over at Alum Rock. It was really on the Calaveras Fault out here. This is a Calaveras Fault. And magnitude 5.6, pretty good earthquake. I remember feeling this earthquake. The Rayleigh wave affected me. I was over in Santa Cruz, and I felt that the house was rocking on a boat. Felt like I was on a boat. And I did, in fact, you can go to the USGS has a website that says, did you feel it? The shake map. Did you feel it? You can answer a series of questions. Were you indoors or outdoors, sitting, standing in bed? And you describe what you felt, and then they give it a ranking of one of these intensity scales. And based on my questionnaires, I had intensity about 4 or 5. You can see that's what most people in Santa Cruz were feeling. If you were over here in Saratoga, Los Gatos, you probably felt more of a 5. And certainly in San Jose, over towards East San Jose, they had 6s and maybe even some 7s. So pretty strong shaking there. So anyways, that's how these maps get produced, by really people getting interviewed and talking about it. And then this is a scenario. So if a magnitude 6.7 earthquake were to occur on the Hayward Fault, remember the Hayward Fault is going to be the most dangerous fault in the Bay Area because it's going to result in the highest intensity, because it's the urban core of the East Bay. We got millions of people living on this area of the fault. Huge high density population, buildings, universities, large cities. There's Cal State East Bay and Hayward. There's UC Berkeley. There's Mills College. So this is a scenario. So right along the fault here, we're going to see intensities of 9s and 10s. So really drastic. And you can see as you go, you're going to see 8s and 7s as you go along farther away. And this is actually for the southern Hayward. It looks like, in terms of the more recent data, the northern Hayward Fault, this Rogers Creek Fault, which is the northern extension of the Hayward, plus the Hayward Fault here, have a higher probability. I think it's a 31% chance of all the faults that this will have an earthquake in the next 30 years. So anyways, that's showing this intensity map here.